We are covering probability distributions for the FE exam, focusing on the three you absolutely must know: binomial, normal, and Poisson. You'll find the formulas for these in the mathematics section of the NCEES FE Reference Handbook. The key to solving these problems on the exam is not memorizing the formulas, but instantly recognizing which distribution applies to the problem statement. Let's start with the binomial distribution. This is your go-to model when you have a fixed number of independent trials. Let's call it N. Each trial must have only two possible outcomes, typically labeled success or failure, and the probability of success, P, remains constant for every trial. The exam will ask for the probability of achieving exactly K successes in those N trials. For example, a problem might state, a manufacturer produces bolts with a 5% defect rate. If 10 bolts are selected at random, what is the probability that exactly one is defective? This is a classic binomial setup. Here N is 10 trials. The probability of success, which is finding a defect, is P equals 0.05. And you want to find the probability for K equals 1 success. You would locate the binomial formula in your handbook and plug in these values. A common trap here involves wording like at most one defect. This means you must calculate the probability for K equals 0 and K equals 1 separately, and then add them together. The exam tests your ability to translate these phrases into the correct calculations. Next is the normal distribution, easily recognized by its bell-shaped curve. This applies to continuous random variables, like measurements of height, weight, or material strength. The two parameters you need are the mean, mu, and the standard deviation, sigma. The FE exam will not ask you to integrate the complex probability density function. Instead, you will convert your value of interest, x, into a standard normal variable, z, using the formula z equals x minus mu divided by sigma, which is in the handbook. Let's consider an exam-style problem. The compressive strength of concrete is normally distributed with a mean of 4,500 psi and a standard deviation of 400 psi. What is the probability that a sample's strength is greater than 5,000 psi? First, you calculate the z-score. Z equals 5,000 minus 4,500 divided by 400, which equals 1.25. Then, you look up this z-score in the standard normal probability table provided in the handbook. This table gives the cumulative probability, which is the area to the left of your z-value. A major trap is not reading the question carefully. Since we want the probability of being greater than 5,000 psi, we need the area to the right. You find the table value for z equals 1.25 and subtract it from 1. Finally, we have the Poisson distribution. This is used for counting the number of events occurring within a fixed interval of time, area, or volume. These are typically rare events, and the key piece of information you're given is the average rate of occurrence, lambda. The formula in the handbook calculates the probability of observing exactly k events in that interval. An exam question might look like this. A water treatment plant experiences an average of 2 equipment failures per month. What is the probability of having exactly 3 failures next month? Here, the average rate lambda is 2 failures per month, and you want the probability for k equals 3 events. You simply apply the Poisson formula. The most common trick with Poisson problems on the FE exam is a mismatched interval. The problem might give you a rate of 2 failures per month, but ask for the probability of 4 failures in the next 2 months. Before using the formula, you must adjust your rate. If the rate is 2 per month, then for a 2-month period, your new lambda is 4. Forgetting to scale the rate is a frequent mistake. To keep these straight during the exam, use this simple mental shortcut, BNP. Ask yourself, does the problem involve a set number of binary trials? Use binomial. Is it about a continuous measurement that follows a natural bell curve? Use normal. Is it counting events per interval based on an average rate? Use Poisson. This quick check will guide you to the right formula every time. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.